2012 problem number 4. The first thing you are asked to do is find the derivative of the function. I see that I have a baby function in there, so when I take the derivative, the outer mommy function is the square root of blah, which is blah to the 1/2. So 1/2 blah to the negative 1/2 is the derivative of the mommy. Then I take the baby. I give mommy her baby, and then I multiply by the derivative of the baby. And given that I can see I'm going to need to write an equation of a tangent line and actually use this to plug numbers in, I'm going to simplify it. My suggestion, though, is for part A, let that lie. You've got your points there. But in part B, you're going to want to simplify it a little. Okay. Part B, equation of tangent line. So setting up equation of tangent line, I know that it's going to be y minus a y coordinate equals slope times x minus an x coordinate, and I have 3 blanks to fill in. The x coordinate is -3. I need to know the y coordinate that goes with that x coordinate, and I'm only going to do that if I plug -3 into my f function. So I've got square root of 25 minus 9 is the square root of 16, and that gives me 4. Then I need to find the slope, and the slope value is for f prime, also at -3. So I'm going to plug that in, and that gives me +3 over that same square root I was just looking at that got me the answer of 4. Equation of a tangent line does not have to isolate the y. So there you go. It's all done. Part B is done. Now moving on to part C, I'm going to erase what I have here to make room. All right, now for part C, I have a lovely piecewise function for g, and it wants to know is g continuous at x equals -3, where this domain splits up. But it specifically tells me to use the definition of continuity to explain the answer. Now you've got to remember what the definition of continuity fully is. And how they decide to grade it point-wise, how much they expect you to show is up to them. So you want to give them everything. For the definition of being continuous, and I'm going to use the name of this function while I'm at it, so g of that x coordinate must be defined. But you're going to have to show that it is. The limit as x approaches -3 of that function must exist, but you're going to have to show that it exists. After you do those two things, then you're going to determine if the answer to that limit is equal to the y value. And all of this notation that you see here has to be written correctly. Now, for being defined, I want to know what g of x is equal to when x is equal to -3. So my equal to sign is right here. And that's why I can say that g of -3 is equal to f of -3. And then f of negative 3 was found earlier to be the number 4, if I'm remembering correctly. So g of 3 is defined. Now, does the limit exist? I have to check my two one-sided limits, and I should show that I understand which side is which. So I'm first going to just write out the limits. And then I want to be cautious about who's the left side and who's the right side. The left side of negative 3 is looking for when x is smaller than negative 3. And that's f of x. So I want to clarify that I understand that this is equal to the limit as x approaches negative 3. Whoops, I just read in the wrong spot. I was here. That this is equal to the limit as x approaches negative 3 from the left of f of x. And then I can use the fact that this is the f of x function. I'm pretty sure that was the function I just saw. Yes. Okay. And then that is equal to, now I can plug the negative 3 in, and I get the number 4. Then for the limit coming in from the right side, I'm going to erase the other highlights. Coming in from the right is when x is bigger than negative 3. So this is now the expression for g of x, x plus 7. So you need to let them know that you understand what is different between the left-sided limit and the right-sided limit. And now I can plug the negative 3 in and get 4. Now, I think it is best if you explain that the limit as x approaches negative 3 of g of x exists because the two one-sided limits are equal, but write that in appropriate notation. And then is finally the last check. And all you have to say is that the limit as x approaches negative 3 of g of x is equal to 4, and 4 is equal to g of negative 3, and therefore this limit, or this is continuous. Thus, g is continuous at x equals negative 3. Now, I wrote a lot of stuff out, and I want to also show you what the AP test says, but keep in mind that they do get to decide how much is enough for you to write. This would be a better way to write it, and I'm finding which one of these is it. No, that was another one. That was another one. There it is. All right, so you can see how they wrote it out and that's what they considered sufficient. And now I'm going to move back to the problem and do the last part. if I can find where I just set my pen down. Why would I have put my pen over there? At least I found it. The last piece is to solve a definite integral. As you look at that definite integral, hopefully you can see the use substitution that needs to take place. I have an inside function under the square root. The derivative is negative 2x. So that means that when I multiply dx over to the right and divide negative 2x over to the left, I can see what to substitute in, and I am shape coding what to plug in. Now, as I'm writing this first bit, I'm going to have x's and u's mixed together. You actually do not have to write this mixture, but a lot of people will. So I'm going to write it out. It's best to not write the 0 and the 5 right now. And in fact, technically right now, it's just a mixture of you're trying to work through it as a step. This is not like what the integral is. Once you have only u's involved, I'm going to bring the negative 1/2 outside the integral. Do not write a 0 and a 5 on there, because that is an incorrect integral. You need to change the 0 and the 5 into values of u, because right now those are on dx's integral, and we're going to transfer them to a du integral. And the rule is the lower limit needs to have its equivalent u go into the lower limit. So if x is equal to 0, I plug that in. Is class over? Oh, okay. Well, I'm going to keep going and you're free to leave. So I plug 0 into the x and I get 25. And then I can plug 5 into the x and that will give me 0. Now it looks like it's backward, but you can change the sign of negative 1/2 to positive 1/2 and swap the order if it bothers you. But know that this is set up to work if you use the rule of the lower limit stays as the lower limit, the upper limit stays as the upper limit. And you should notice if you see why they change, that little negative sign right there. That negative sign created this negative sign, and it also caused their order as far as being a smaller to a bigger number to swap as well. So realize that there is a compensation that goes along with just keep it where it is. So now I integrate and I add 1 to the 1/2 exponent to get 3/2, multiply by the reciprocal, I've got a times 1/2, 0 to 25, and then I plug it in, and that gives me 125 minus 0 times the 1/3. And then I'm done. Yay!